All right, so this video is going to be about power series and the interval of convergence. So we kind of looked at this new type of series that we're going to see yesterday, where we were looking at polynomials with the Taylor and Maclaurin polynomials, but you could kind of see how they might be a series because you were like repetitively adding something together, and that's what the definition of a series is. So we're going to look more at this today, and we're specifically looking at what we call a power series because it's going to be something to the nth power. So you'll notice between yesterday and today, if we're talking about those polynomials as a series, that you have like something in front of, and you have two variables. You have an x, that's the part of it that's the polynomial, but then you also have an n for the nth term. So the first term in the series, or I guess that's zero, first term in the series, second term in the series, third term in the series, etc. So that's kind of what differentiates this unit, I guess, from the last unit, is that now not only are we talking about individual terms that add up to be in a series, but we're getting a little bit more complicated because our series can be represented as a polynomial. And so we want to learn different things about that polynomial. So when you look here, the idea of the series or the polynomial being centered at C, we kind of saw that yesterday in the Taylor series. The way that they phrase some of the questions, they would either say that the original function that you were looking at and defining by a different polynomial, that it was centered at C. So in the Taylor series, you might have seen some problems that had x minus 1 or x minus 2 in them. In the Maclaurin series, they were always centered at 0, so you never saw a C value. It was always just plain old x. So we're going to be looking for that center today. And that center today is going to help us to figure out what the interval of convergence is. So we have three different situations, and it won't make a lot of sense necessarily when I'm talking about it right now, but it will make more sense when we start to look at examples. So the first situation is that the series itself, when you evaluate the series, it appears that the series diverges, and so we would say that it only converges in one spot, and that's at the center. That's like the only place where you can see what it would converge to. And then the rest of the time you would say it diverges. And I went ahead and highlighted this because even if the entire series diverges, you would still say that the power series converges at its center. So the rest of it might diverge, but it's going to converge at that one spot. Another situation could be when you're evaluating the series and you find that it converges absolutely, then you would say it converges for all x's in the domain. And then the last situation is maybe it converges, but only for a specific interval, and we're going to look at how to do that. All right, so this, again, it will make more sense when we start to move on from this. So I borrowed these notes from another teacher. I did not get to retype them for you. That means that these notes definitely, there's not much space to write here. So I'm going to go ahead and write the notes on a separate sheet of paper. One thing that you'll want to keep in mind is that we typically will use the ratio test when we're testing for the convergence and to find our interval, but sometimes we'll use other tests. And that in the situation where we do have an interval with specific numbers, we are going to have to test the endpoints to see if they should be included or not. And again, I'll give you some examples of that so it will make sense. All right, so for the first example, it says find the nth term for the power series f of x is e to the x, and that was one of the ones that was in the notes yesterday. So you might recall that when we did this, when we found the derivative, we were actually using 0, and we found that the derivative of that was just e to the x repeatedly, and that when you plug in 0, you always get 1. So when we wrote this, we were doing a Maclaurin series because it was centered at 0. And then the coefficient always happened to be 1. So it gave us the polynomial 1 plus x squared over 2 factorial plus x to the third over 3 factorial. And then as it continued on forever, it would be x to the n over n factorial. And that's, you can kind of remember that polynomial. That was one of the like shortcut ones. We said anytime you're looking at this function, and this would be the polynomial that you could use to approximate some values for it. So if we look at this one, if you were to put parentheses around the x, right here, like I said, this would have been a Maclaurin series. It's that specific example where in your parentheses you technically have x minus 0, and so the center of this is 0. And then for us to test for the radius and for the interval of convergence, we're going to go ahead and do the ratio test. And the ratio test will work on a lot of them, not all of them, but a lot of them. So for me to do the ratio test, I'm going to take this one down here, the one that represents the entire polynomial. So we're going to say that this polynomial is the same as this series. Actually, I guess that would be 0, starting at 0. So now instead of looking at this polynomial, I'm going to look at the series and see where it converges. So I'm going to do the ratio test. That's the limit as n goes to infinity of x to the n plus 1 divided by n plus 1 factorial over x to the n over n factorial. And I'm going to go ahead and bring the bottom up. Bring the reciprocal up. So if I rewrite this one, that's x to the n times x to the 1. And this, if I rewrite it, is n plus 1 times n factorial. And so then I can see that n factorial cancels with n factorial. And I can see that x to the n cancels with x to the n. And so I'm really finding the limit of x over n plus 1. So as n goes to infinity, this limit is 0. Notice I'm not thinking of the infinity being plugged in for x. This says as n goes to infinity, so I'm just thinking about plugging infinity in for n. So the limit is 0, and if you guys recall, anytime the answer to a ratio test is less than 1, that series converges absolutely. So if this converges absolutely, that means for all x. For all of those x values, it doesn't matter what number you plug in, the series is going to converge. So that means that the radius of convergence is infinity. It always converges. And that means that the interval of convergence is from negative infinity to positive infinity. So if 0 is the center of that, then negative infinity, so that's the left side of 0, positive infinity, that's the right side of 0, so it converges always. All right. Example 2 is really 4 examples. So again, we're doing the same sort of thing, looking for the center, the radius, the interval of convergence. If you write real small, you might be able to fit it in this space. I'm going to go ahead and write it on a separate sheet of paper again. So, example 2, part A. This problem, they're not giving it to us written as a polynomial. They're just going to go ahead and give this problem to us written as a series. So if you look, you can see what the center is. It's 5 right there, so center is 5, so you can always see it. It's whatever is being subtracted from the x in the parentheses. And then we're going to be finding the radius, we're going to be finding the interval. So again, this is pretty well set up for the ratio test. So I'm going to go ahead and do that. So in the ratio test, we always have the +1 version on top. Any place we see an n on the bottom, we have the regular version. So I'm going to go ahead and multiply this by the reciprocal. All right, and for this piece, we can rewrite this as -1 to the n plus 1 times -1 to the 1. That's where n plus 2 came from. This one we can rewrite as x minus 5 to the n times x minus 5 to the 1. N plus 1 we can't rewrite as anything. 2 to the n plus 1 we can rewrite as 2 to the n times 2 to the 1. And then we can go ahead and see what cancels. So -1 to the n plus 1, x minus 5 to the n, 2 to the n, and then we'll go ahead and write our leftovers. So we're going to do the limit as n goes to infinity of, I have a -1 left on top and an x minus 5. And then on the bottom, oh, and I also had an n on the top. And then on the bottom, I have an n plus 1 and a 2. All right, so we have to think about the limit as n goes to infinity. So we can see that these two n's are exactly the same size. The -1 doesn't really make a difference because of the absolute value. So these two n's are exactly the same size. The x minus 5 is the coefficient for that n. And the 2, if I had written it over here, the 2 is the coefficient for that n. So the limit as n goes to infinity, since the n's are the same size, the limit would just be the coefficients of n. So the limit is this. So this is a more interesting case. This is not like before where we can just say, oh, that's a number, so that's the number 1/2, or that's the number 0 or something, so we know that it converges absolutely, or say like, that's 5/2, that's bigger than 1, so it diverges. It's not one of those situations. This one would converge, but it depends on what the x value is. So we know that if this fraction right here is less than 1, then whatever x values make this less than 1 is what would make it so that this converges. So now we're going to go ahead and figure out what our interval of convergence is. We're going to say x minus 5 over 2 is less than 1 is where it would converge. I'm going to go ahead and multiply by 2. So the absolute value of x minus 5 is less than 2. So anytime, this is where our center was, remember our center was at 5. So anytime we're within 2 of that, that's when we're going to have convergence. So our radius of convergence is 2. The center of convergence is 5, the radius of convergence is 2. So that means that our interval of convergence is between 3 and 7. So 2 down from 5, 2 up from 5. Now I have to test and see if you can converge at 3 and if you can converge at 7, because I don't know if I should say that these numbers are included or excluded. So that's the next thing we have to test for. So I'm going to go ahead and put that on the back side. If you've got room, you can put it where you've got room. So I'm going to go ahead and check 3 first. So that means I'm just going to write out the series, and I'm going to plug 3 in only for x. So this has nothing to do with what term I'm finding. This just has to do with if I use that specific x value, then what happens to the series? Does it converge or diverge? So,
sorry, I can only search by topic for movies.
Siri thought that I said Siri, not series. So this is -1 to the n plus 1 times -2